Hey everyone, so this video is going to be about entropy, and I probably wrote something about abortion in the description for like clickbait. So I'm sorry about the clickbait, but it will be about abortion, and it will hopefully resolve abortion based on physics and entropy, which maybe if you know about entropy, you might see where it's going. But we'll get started. So entropy, what entropy is a measure of, it's in physics. Entropy, it's like this. It doesn't seem like it's fundamental to the universe. Entropy, it seems like it comes out of what the universe is. It comes out of the fact that there's space and there's time, and just entropy sort of comes out of this, right? But it's so fundamental, not only to physics, to just everywhere in just all of the universe. It's just like this very unstoppable force, entropy. And what entropy is it's just this increase in the number of states that the universe can be in. It's this increase in disorder, chaos, if you like. These are I'm like, these aren't physics terms. These are just so you get the general principle terms. So don't jump on me for not sticking with physics. And also generally, entropy is a decrease. As entropy goes up, it means energy is getting more spread out. It's like a measure of how much energy is spread out in the universe, okay? So when all of the energy was together in the universe, it had zero entropy, right? At the time of the Big Bang, we had zero entropy everywhere. There was an infinite energy density, okay? And an infinite energy density is zero entropy. It means the energy was so organized and so structured that it all completely fit in a point, right? And today, you can't push things together more than that, right? Black holes take up size, right? Take up a certain dimension. You can't fit them into a smaller area. But there's this limit that I sort of touched on the last time, that the information on the circumference of the black hole has to pertain to the information what's inside, right? So to the volume. So in this way, there was just like this huge superstructure of all of the energy, just at an infinite level. And what I wanted to touch on was this idea that Newton, Sir Isaac Newton, came up with in order to grapple with the universe, in order to and it's just basic calculus. It's just approaching these zeros and these infinities, right? He invented a way to get closer and closer to something without actually getting there, because the formulas or the equations just sort of explode or do something really funny when they get to zero or when they get to infinity. And these are like the limits of the universe, is this zero and this infinity. It's just this all pervasive thing, right? So for example, time zero, just 1 second, let me just share something here. If I can share new Google tab. There we go. Share this thing here. All right, here we go. Okay, so I'll just type in the Google search, y equals 1 over x. Just have a nice little graph here. All right. Okay, we'll zoom in on this graph. All right, so this is what happens. Okay, this is what it looks like. So time, for example, at time zero, what's happening? At time zero, we're getting the energy density is going to infinity, right? We can keep going up and up and up and up, and we'll never get to zero. We'll never reach zero. We'll just keep getting closer and closer and closer to zero. Okay, someone's calling me. I'll just stop it for a second. Yeah, sorry about that. So we can keep going forever, and we'll never get to zero, okay? That's just the way it works. And so at zero, as we keep approaching zero, the energy density reaches infinity, and the entropy reaches zero as well with time. And as time extends, entropy is just going up and up and up, and time is going up and up and up, but we'll never ever get to a zero energy density, right? We'll never get there. Okay, so let me just stop the share. So this is just the basic graph, and just so you know, economics also follows this kind of graph. A lot of things follow this kind of graph where like all of the values is in a very small region, and then all the rest is all spread out. So, okay, so it's just the basic idea. So when we're talking about entropy in this way, entropy is going up and up and up. We're getting to less and less dense energy, and entropy is a measure of how useful energy is. Okay, so if energy is very useful when it's very dense, right? If you have a battery that's completely charged, you've made that energy really dense, and now that energy wants to spread out, right? That's what energy wants to do. It wants to increase the number of states. And so that's when energy is useful. And another analogy, you take a car, right? A car is exploding all the time, this gasoline, and it's igniting it and spreading it out. It's making it into a gas that's spreading out. So it's increasing this entropy. You're getting a lot of energy for that, right? But like, say you were to take this car and try to drive it at the temperature of the sun or of Mercury. You're driving it on Mercury. So Mercury is just so hot, the car can't drive there because there's no gradient in energy, right? You need a gradient. You need energy to flow from one place to the other in order for something to happen. So you can light your car, but your car just won't do anything. You can ignite all the gas. Well, obviously the gasoline will just explode at the beginning, but you get the point. You need this gradient. You need energy to go from one place to the other, and that flow, when entropy is going up, that flow and the energy is spreading out, that's where we get our work from. That's where we get our ability to do things. Okay? And so what happens is there are places where entropy goes down. Like I said, you can charge a battery, and what's going on, you're making all the energy into one spot. But what happened? Entropy is supposed to be going up throughout the entire universe. Well, actually, when you charge your battery, you're producing a lot of entropy. First of all, you're producing that entropy by making the energy compact in your wall, like you're charging it through your power plug in your wall. So you have to create entropy in order to get that electricity into your wall. And then you also have to, when the battery is separating and getting more organized, it's separating the ions and things. So what happens is it's getting hot. It creates a lot of heat. And what is heat? Heat is also an increase in entropy because you're getting rid of all of these photons. All of this energy is just spreading out into the universe like infrared energy, right? And so that's really this process that happens. So you can locally, like in the battery, reduce entropy, but you have to overall increase it in order to get that work done, right? You have to have that gradient, and you need to get that work done somehow. All right. So the same thing with a star, for example. Okay. So a star is what it is it's just all of this mass, and mass is energy. It's all this mass is coming together, right? It's all this gas, all of these gas atoms, hydrogen and helium atoms are coming together. And as they're coming together, what happens? They heat up, and they're getting closer and closer together. The energy is getting more and more dense, right? But it's getting more and more hot. It's producing more and more heat, and the entropy is increasing overall. And then what happens is, in the center of these stars, you're getting this larger energy density too. You're getting nuclear fusion. You're getting these atoms that are going up and up in number. So they're turning into iron and things like, and even like uranium and things like this, because the hydrogen ions are combining with more and more hydrogen and more, and you're getting all these protons and neutrons combining together, and it's getting really, really dense. And that's why the sun is just so hot, and it's producing so much energy. And the earth away from the sun is able to absorb this low entropy energy. Sunlight in the visible spectrum is low energy, low entropy. And what we do is we absorb this low entropy and convert it to even higher entropy in order for us to live, in order for organisms to live. And organisms the same way. In a pregnancy, for example, this video is about abortion, so we can talk a little bit about a pregnancy. Is what you're doing is the information. So energy and information we talked about last time, it's quite similar in the way we understand it. And information structure, a structured form of information, the child, the way the child is getting formed in a very structured and ordered way, right? there's lots of ways those molecules can combine, right? You have carbon, you have nitrogen, plenty of ways those carbon, right? It's just like, it's not very likely that those molecules will combine to form a child, right? It's not very likely. It's very structured in order to form that specific child. So when you're forming this child, you're going against randomness. You're going against chaos. You're causing some kind of order. And so this is how organisms go against that. And how do they do that? Because we're expending energy. We're expending, right? Energy can't be destroyed, but we're increasing the entropy of the energy in our bodies in order to do that, right? It's fueling it. Okay. So similarly, if we look at just information and we ignore energy for now, okay? So even organizing information takes energy, takes this, organizing information is reducing the entropy. And so that means we have to increase entropy, we have to do work. And so over generations and generations, in every domain of knowledge, humanity has been reducing entropy. We've been zeroing in, we've been structuring it more and more and more. So it means that, like, for example, our court system, right? So at some point, our court system was chop off their heads and like just really chaotic and unorganized and not focused and not information efficient. And I'm not saying we're perfect today. We're actually really far from perfection today, but we're getting closer to it because we're structuring our system, our societal systems. Same thing with economy. Same thing with physics, right? Physics today is a lot more information dense. It's a lot more, the information, all of that information could have just been like, okay, so you got the example of the chimpanzees typing on the typewriters, right? And you've got 100,000 chimpanzees typing on typewriters, and you think, okay, maybe Moby Dick will come out. Maybe some super amazing novel will come out. And really, maybe a word will come out every so often, or a sentence that sort of makes sense, right? And so that's the thing. Can randomness create this order? And so our knowledge in physics could just have been a whole bunch of gobbledygook, a whole bunch of just monkeys typing on typewriters, and it could have just not been true and not been organized. And the thing is, when we're increasing the structure of information, getting closer and closer to truth, right? We'll never get to truth, we'll never get to perfection, but we'll always keep getting closer and closer, and we're refining it. So that the likelihood that a chimpanzee could randomly type out this information is just getting lower and lower because it's more true and more structured, right? It's just super unlikely that we would type out a perfect sentence that encapsulates all of the universe in one beautiful sentence, right? So same thing. Like there's lots of examples of low entropy formulae and things like this. Okay, so I'm going to go back to this share thing here. 1 second. Just bear with me. Here we go. Okay. Where are we? Okay. So it's the same thing. As time progresses, okay? As time progresses, energy is getting spread out and spread out and spread out, but we are approaching a perfection. We're approaching our systems are approaching more and more perfection, and we'll never get there. And obviously, eventually, our ability to do work is going to disappear because the energy density in the universe is just going to be so spread out. But let's just ignore that for now. We've got at least 10,000 years, 100,000 years, 200. Like it's for us, it looks like an infinite amount of time. So we're asymptotically going to keep approaching some value. So this is actually kind of the wrong graph. It's the kind of the inverse of this, where you're going to approach some specific value. So the same thing. I'm going to step back a little bit and talk about particle accelerators, for example, right? So when particle accelerators are increasing this energy, they're getting closer and closer to the zero time. They're getting closer and closer to the Big Bang because they're approaching the speed of light. Same thing. You need like a little bit of energy to increase your speed this much. You want to increase it more, you need a little bit more energy, and you need more, and just to increase your speed by 1 meter per second now doesn't take a lot of energy. But if you're like so close to the speed of light and you want to increase your speed by 1 meter per second, it'll take just so much energy, so much more energy, right? This is just this calculus that the closer you want to get to the speed of light, the more and more energy it'll take until it takes an infinite amount of energy to get to the speed of light, right? for mass at least. Okay, I'm gonna come back here. Stop share. Okay. Okay, so if we think about the infinite future of humanity, so the infinite future of humanity without, say, we can just keep going forever and getting better and better and better, we're thinking that we're eventually going to reach this, if time equals infinity, as time increases, like we can use calculus to say, okay, in eternity, right? Eternity is when time is equal to infinity. All of our systems will be perfect, and we'll have this perfect utopian system. Okay, that's the basic concept. So 1 second, I'm in the middle of something, so just go and put something. Okay, sorry about that. Okay. So so we can think we're just going to constantly keep getting closer and closer to some perfect system. So this is the way that I see these types of conflicts today. Okay, so abortion, for example, this abortion conflict. Sorry. So these conflicts, basically, they abortion conflict, for example, it's really this dynamic that we're talking about when we're seeing pro-choice versus pro-life. Okay, so you're seeing one group of people who are looking at time zero. They're looking at now. They're so focused in the moment where things aren't perfect and where things can go wrong. For example, anytime you want to have an abortion, it's because some mistake happened, in your opinion, at least, or an abortion is just a symptom of some kind of imperfection. And the most obvious case, the case that everyone would agree upon, is the case where a mother might have been in like a car accident or something, and she's bleeding out and she's in a coma, and in order to save her life, you need to abort the baby, right? And now obviously medicine will increase, and that'll happen less and less. But so you have this need for an abortion now because of the imperfection of the world, the way the state of the world is things, right? The state of the world. And so all abortions are this form of imperfection. But you have the people who are focused on now, and they're saying, no, pro-choice is perfection. Pro-choice, what they're doing is they're saying, let's stagnate. Now is perfect, is what they're saying. Basically, they're saying now is perfect. Let's stagnate, and that's incorrect, right? What you want to say, where these two views converge, is where you say we need to create a world not where abortion is illegal, but a world where abortion is no longer required. We don't need to do any abortions anymore because every pregnancy is going to be a wanted pregnancy, and every pregnancy is going to be safe from something that will force it to not, right? So, and then on the other hand, you have the people who are looking at this infinite future time, or their descendants that are just sort of traditional and want to keep their parents' views. But in essence, they're looking at this perfection where abortion is just an imperfection. And they're saying, okay, well, let's oppress people now because abortion is imperfect and we want perfection now, which is also wrong, right? You can't force perfection now. That's just oppression. You have to get to it gradually. You have to get there gradually. And so both of them are going to not allow us to progress. Okay. One of them is not going to allow us by having stagnation, and the other one is not going to allow us to progress by forcing it forcing it now and having us, sorry, it's not loaded how it works, but at least they're not. Maybe someone can mention in the comments, because I'm thinking a little bit. Yeah, sorry. But anyways, so you have these two sides. One side is looking at this eternal perfection, and one side is looking at what is necessary now. And if you see it for what it is, then both sides will end up agreeing. They will end up agreeing that we need to start working and progressing, making things better one day at a time, so that one day we'll like, maybe let's say today there is 1,000 abortions in a year in some region. Okay. And so maybe in 100 years from now, it'll go down to 100 abortions in this region per year. And then it'll go down to 1 abortion per year eventually. And we want to get to a point where there's no abortions per year, where where people are responsible, people, all pregnancies are wanted, and there's no more need for abortion. Not that abortion is illegal, it's that there's no more need for it. And then all sides will be happy, right? People who are anti-abortion, they'll be happy because there won't be abortion, and people who are pro-choice will be happy because people have the choice, even though they will never actually need to utilize that choice, right? And so that's basically the way these dynamics play out. And so this is something that happens like a lot. This is a standard type of conflict, and the reason why I chose abortion is because it's just a little more evident of how this conflict plays out. But we have to be careful about the stagnation, about the people who idealize the now, who say now is the eternal perfection. Abortion, pro-choice is the ideal. No, it's not, right? Or people that say the ideal needs to happen now, and no, that's bad. That's oppressing people. That's forcing them to be somewhere that they're not. And it's like bordering on totalitarianism or whatever, right? And so and as long as this conflict happens, people are getting forced and more polarized, and they're not meeting in the location where they agree that we need to grow out of this. We need to reduce entropy, and we need to perfect this location of conflict, right? So, okay, so this is just a conflict resolution for this type of problem. There are other types of problems, okay? This is one type of problem that is quite prevalent. It's the problem of time. It's a problem of eternity versus instantaneous now, and how we see the now as eternal, or how we see eternity as it should be now. We should make utopia now, right? So I hope it made sense. And yeah, have a good one.